Hello and welcome to the week 4 wrap-up video. This is a bit of a longer video because I do go through some of the stuff from the Knowledge Check 4 feedback, but then I also walk through the solutions for assignment number 2 on modeling, as well as the first and second connections exercises. So stick around if you want to walk through those and see how those, what the solutions are. I have posted solutions for all of those. So if you're good to go, you don't need to watch this whole thing. But just a heads up, it is a little bit longer because I am going through those solutions. I also talk a little bit about the differences between the 4 machine learning models covered. So decision trees, random forests, support vector machine, and neural networks, which is actually optional. I'm not testing you on neural networks, but I do have an optional hands-on video that's posted for that. I also walk through a little bit of the difference between precision and recall and why you might prefer one versus the other when looking at your model's accuracy. So there's a bunch that I go over in this video. So let me go over to my keyboard, do all that, and then I'll see you on the other side. Okay, a few things came up in the feedback and Knowledge Check 4. A couple people had asked about when to use each of the machine learning models that we're covering. So in the course, we went through decision tree, random forest, support vector machine. It's optional, so you didn't have to watch the video for doing neural networks, but obviously that's another type of machine learning model. And so we applied all of those models to this credit card default question. But a few people sort of wondered, when do I use one model versus another? Okay, so one of the beauties of machine learning, particularly using sklearn as we've been looking at in this class, it's actually very simple once you set up your data to kind of try a bunch of different models and a bunch of different parameters. We're, by the way, not getting into like tuning your models. You did more of that in DA1. This course, because we're covering a broad range of topics that are managerial, we're not diving quite as deep into the models as you did back in DA1. But, you know, one of the nice things is you can run a bunch of different models. You can tune your models in different ways and set the parameters to different settings to see what gets you the best accuracy, right? There's very little cost to that. Although I will say if you're working with very, 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 very large data sets, the computing time might actually be more significant. Certainly what we're doing on our laptops, our models run pretty quickly. You know, if you're working with millions and millions and millions of rows, the models might take longer to run. Now, obviously, companies often have much more high-powered computers to run a lot of these models, but just to kind of give that heads up. But I thought I would kind of walk through like when people typically use the different types of models that we covered. And so if you think about a decision tree, the nice thing about a decision tree is it's what we call a white box model. You can actually look at the tree. You can look at the split points. And so if you're building a model where you're trying to understand like a set of rules, or you really want to understand like when, you know, which factors predict one thing versus another thing, decision trees are really good at that. Okay, so the example here, a lender might use a decision tree model to understand risk based on different factors for one of their customers. Okay, credit history, income, other financial attributes. And the nice thing is when you build the tree, you can actually see where the splits are. So it's nice for that to kind of give you a set of kind of decision rules. Okay. Now, one of the risks or one of the downsides to decision trees, as we've discussed, is they're often very highly overfit. And that's where the random forests come in. Okay. So random forests, they are essentially a bunch of different decision trees being run. So once again, you know, they're good for interpretability, but more importantly, they're used to control overfitting. Okay. So if you think about something like a patient diagnosis based on complex patterns, you know, maybe you're trying to predict if someone has diabetes. You know, you don't want to get that. You want to be more accurate with that, right? And so overfitting can be a problem for those types of more costly types of errors. Okay. When it comes to support vector machines, these tend to be very good when you don't have a huge data set, but you have a lot of features. So think about data sets where maybe you've got like 50 to 100 columns, but you don't have a ton of rows. Support vector machines actually work really well in those scenarios. Okay, so my example here, bioinformatics. So you're trying to classify proteins or gene expression profiles or cancer types based on biological data. You typically don't have massive data sets, but there are lots of features in those data sets. And you'll find that support vector machines tend to work really well with that type of data. And then finally, neural networks, because they're really good at modeling complex patterns, you're typically going to use those when you've got unstructured data. So textual data, pictures, video, things like that. On the slide here, it says week 9. I apologize. This slide is from my 14-week course. But if you watch the optional video on the hands-on for artificial intelligence, I walk through using a neural network model to do a sentiment analysis with some IMDb movie data. Okay, so if you're interested in that, take a look at those optional videos. Again, I'm not going to test you on that, but that'll give you a good sense of that. So neural networks tend to be good for complex data, unstructured data. Okay. The other question that came up, which I think is a really good question, had to do with the difference between precision versus recall. It does get a little tricky to kind of get those things straight in your head, precision versus recall. So I thought I would kind of walk through examples here. So let's start with precision. So precision, the idea of precision is when the model predicts that something is positive, how often is that positive prediction correct? Okay. So back here, actually, if we look at like the actual the actual calculation, it's the true positives over the true plus false positives. Okay, when the model predicts a positive value, how often is that correct? So the example here, let's say that you've got a model that's trying to identify spam emails, and this model is being used to automatically send spam emails to a spam folder. Okay, so it's kind of important that you don't accidentally get legit emails sent to that spam folder. Okay, so in this case, a false positive would mean that a legitimate email gets moved to the spam folder. Okay, and that could be more costly to you. So in other words, it's less costly for you to get a spam email in your inbox where you just manually delete that versus a legitimate like business email gets sent to your spam folder and you didn't even see it. And I don't know if you've ever done that, but every once in a while I will check my spam folder and I'll just kind of go back a little ways. And occasionally I do find, knock on wood, I haven't found really, really important emails there, but occasionally I will find emails there from, let's say, businesses that I actually use that I wouldn't consider spam. So it happens. And so missing an actual spam is less costly than hiding an important business email. So in this case, with this type of model, you would want high precision. Okay, you want to know that when the model says spam, you can be confident that it's spam. Okay, so that's precision. What about recall? So recall is of all the actual positive cases. Okay, so just to be clear, precision was about the predicted positive cases. How often is that correct? With recall, we're actually looking at the positive cases. And of the actual positive cases, the real positive cases, how many did the model find? Okay. So the example here, let's say that you're building a model to screen patients for a serious disease. You're screening for like cancer, let's say. A false negative means that a sick patient is told they're healthy. A false positive means a healthy patient undergoes additional testing. So again, we're thinking about costs. And that's really where the difference between precision versus recall matters, is you want to think about which type of error is more costly. So in this case, the false negative is more costly. Okay, missing a disease is usually worse than ordering extra tests. So high recall is the priority. You want to make sure that this doesn't happen. Okay, this might be a little bit more costly for a patient. It may be more inconvenient, but this is where health outcomes can potentially be worse. Okay, so hopefully that kind of makes that a little bit easier to kind of think through the difference between precision versus recall. Let me go over to Jupyter Hub. couple things I wanted to go over, but first thing I wanted to go over in the predictive modeling worksheet, a few of you pointed out an error in the script and the difference between the script and the video. So I just kind of wanted to walk through this. So in the original script, I had this pandas.valueCounts for pred tree train, and you're getting this error. So some of you actually looked this up and found this correction using pd.series, okay? And by the way, in the solution file that I posted, this is actually what I had. I had forgotten to update this on the blank file, but I did update this on the solution file. This was already there. I have since gone in and refreshed the original predictive modeling file to use this code instead of the original code here. This is just, again, Pandas has changed a little bit. It used to be that you could do this. You can't do it any longer, okay? If you wanted to do something like this, where you wanted to use value counts the way that we've used it in the past, the issue is that pred tree train is not in a data frame. It's just a series, right? So when I ran this code up here for pred tree train, I get this array. It's not actually a data frame. And it turns out that pandas won't just simply work on a series like this, an array. And so instead, the way that I need to do this is I have to kind of use this series function, which basically gives pandas the heads up that, hey, take this array and let's treat this as a data frame series and get value counts for it. Okay. If you didn't want to do that, I just, this is not in your script, but, well, unfortunately, my, my Jupyter happened to refresh just as I was walking through this. So let me quickly get this back open. Okay. And let me open this back up. I think this is the worksheet. Let me just come down here. Just kind of walk through. This is not in your script, but another way you could do this is, because value counts wants to work on data frames, is to actually create a data frame. So in this case, I'm using this data frame function from pandas, and you have to give it data. And so in this case, I'm creating a D variable for data, where I'm taking my outcome trains array and putting that in a column that I'm going to call outcome. I'm taking my pred tree train array, putting that in a column called pred, using this data frame thing. And then notice here, it actually creates a data frame now with an outcome column, a pred column, and then guess what? So I called this data frame temp outcome dot value counts. Okay, temp pred dot value counts. Okay, that's another way you could do this, but obviously that's a little bit more work. By the way, once you have it as a data frame, you can actually do a crosstab. Actually, I didn't even need a data frame for this. Crosstab works with just the arrays of data. And notice, if we use a crosstab to compare outcome train to pred tree train, I get the same exact numbers as down here when I use this confusion matrix. Okay, 44, 67, 11, 36, 15, 5, 86, same numbers. So in effect, the confusion matrix is just a crosstab. Okay, so I wouldn't worry too much about this. I'm not going to test you on this. To be frank, the only reason I kind of walked through these examples was to give you the rationale behind the confusion matrix. When it comes to machine learning, I just use a confusion matrix and the classification report. I don't actually use value counts for this. And so, it's unfortunate that the script was a little bit different than the video and that this version no longer works with pandas. But honestly, you probably would never be using pandas to get value counts for your machine learning model. You would be using a confusion matrix, okay? And so don't let that discrepancy confuse you. It really was just for illustrative purposes. Okay. Couple more things to go over. While I'm in here, let me just point out a couple files that I've posted. So if you kind of scroll down under M, I have now posted a file called ML regressor models. And all this is, it's still using credit card default reduced, but it's walking through the 4 different machine learning models and how you would use it if you had a quantitative variable. Okay, so we covered classification models, models where we were looking at whether or not someone paid or missed their bill. That's a categorical variable, our outcome. In this case, what if my outcome variable was how much did someone pay? That's a quantitative variable. I cannot use a classification model when I've got a quantitative variable. Okay, so how do I do this? Well, first of all, you still have to set up your data. Your outcome in this case, instead of being categorical, would just be a numeric. But in terms of features, I still need everything to be numbers or trues and falses. So I still need dummy variables. You still need to partition the data. There's nothing different about that. When it comes to the actual trees, though, notice, so before in the models we looked at in class, we said decision tree classifier. Well, notice there's something called decision tree regressor. Okay. Similarly, we looked at random forest classifier. Well, guess what? There's a random forest regressor. We looked at SVC, which stands for support vector classifier. Well, there's an SVR, support vector regressor. And then finally, neural network, again, we didn't really cover this. It's optional. But if you looked at the optional video, the classification version of this is called MLP classifier. Well, guess what? There's an MLP regressor. Okay, so the major difference is if your outcome variable is numeric, instead of using a classifier model, you would use a regressor model. The other big difference is with classification models, again, when we're trying to assess how good the model is, we look at the confusion matrix, we get the accuracy score. What's the percent accuracy? Well, when it comes to numeric variables, we wouldn't be using that. Now, one thing you could use is actually you could use, sklearn does actually have an R2 score, which is R squared. So with these types of regressor models, you actually could use R2 underscore score, and it would give you the R squared score for these models. But in practice, when it comes to machine learning, people typically do not look at R squared. Instead, they use something called RMSE. RMSE stands for root mean squared error, RMSE. It's basically the average amount of error there is in the model. And so the way that you would do this is you can get the mean squared error from sklearn metrics, and then you just get the square root of that, okay? So mean squared error is the MSE, and square root is the R, RMSE. And this is a number, it's the average amount of error. So unlike accuracy, with accuracy, the higher the number, the better, right? An accuracy score of 99.76, that's very high. When it comes to RMSE, the higher the number, the worse. Okay, in this case, you want a lower number because it's error. So you want less error. And so this is the RMSE for the decision tree for the training data versus the test data. And once again, just like with the accuracy scores in a classifier model, we can also kind of see here, there's clearly overfitting, right? The model has much less error when it comes to the training data than it does when it comes to the test data. So we've got a huge error, a huge overfitting problem. If I look at the random forest, again, overfitting, support vector machine. Interestingly, like with the training data, it's not as good, but I don't really have so much of an overfitting problem. Okay, and this is 16089. I think that's the lowest so far in terms of the test RMSE. And then neural network, again, not really an overfitting problem. And this one even has a lower RMSE for test. So in this case, the neural network is modeling the payment amount. Remember, that's what our outcome variable in this example is the payment amount for someone's credit card payment. Okay, so I have posted this. I'm not going to test you on this. I just wanted to kind of show you all of these models have a regressor version, and they're run very similarly, although the actual function's a little bit different. And instead of accuracy, you're going to be using RMSE to score these models. Okay, so I did want to go over that as well. The last thing I'll point out while I'm here is I did send out an announcement yesterday, but I'll just point this out. You should now have two files here. So you've got final exam practice problems. This says solutions. It doesn't have the solutions. Sorry. Here are the solutions. Okay. So the solutions file has the solutions. The blank file just has questions. And so I recommend take a look at this. The vast majority of this are Python coding questions, although at the end I do give you some sample managerial types of questions. In the solution file, you can look at the solutions um, for all of the Python coding questions, but I have not provided solutions for the managerial questions, and that's mostly because I sometimes reuse these questions. So if I give you the solution, I can't use these questions. And so this is just to give you a sense of the types of questions I could ask. Okay, so I do recommend taking a look at these final exam practice problems. To be clear, I've given you many, many more questions than will be on the exam. Okay, this is a pretty long set of questions. As you're going through this, don't freak out that, oh my gosh, there's going to be this many Python coding questions on the exam. There will not be. I think it's better to give you more questions to be able to practice than fewer questions. Okay, so I just wanted to point that out. If we come back over to the Canvas course page, just to remind you, so we're in this week right here. We're in week 5, I believe, of the course. So in terms of what is due for next week, your final knowledge check 5, and the final assignment on visualization. Those are both due on Monday. Just a heads up, because the exam goes live next Monday and is open all next week. This visualization assignment, because I want to be able to post the solutions right away, there are no late submissions for this. You do need to get this in by end of day on Monday, because I will be posting the solutions on Tuesday morning so that you can at least look at the solutions before you take the final exam. Okay, so on this final assignment, you do need to get this in by Monday. Okay, I don't think it'll take you that long. Basically, this assignment, you're creating 3 different graphs. Okay, if we come over here to the assignment worksheet, you're basically creating 3 graphs. Okay, and I've described the graphs for you. Okay, you do need to use Plot9 for all of these, so don't use Matplotlib. You'll lose tons of points if you use Matplotlib. The whole point is to get practice with Plot9, with ggplot, okay, which is what I cover this week in the hands-on videos. Okay, so for Monday, knowledge check 5 and assignment 3 are due. And then, as I said, the only thing that's going to be due next week is the final exam. It will open on Monday morning, and it will close end of day on Friday. That's the end of the semester. Okay, you'll have 2.5 hours to complete this. It'll be a mix of both Python coding questions as well as managerial questions. And you cannot use AI. Okay, so obviously you can use Jupyter to run and test your code, but you cannot use AI. And just a heads up, just as with the assignments, when it comes to Jupyter Python coding, I'm grading you based on the coding that we've covered in class. So if your code veers too much in different directions, you're going to lose points. Okay, part of that's my way of making sure that you're not using AI tools, because as some of you on the assignments have learned, sometimes the AI gives you different code. So even if the code gets you to the same answer, if it's not code that we covered in the class, you're going to lose points, because I'm testing you on the code that we covered in the class. Okay. Having said that, I have posted now the solutions for the first and second connections exercises, as well as assignment number 2. So just quickly, let's kind of go back to those just to walk through them. So if I look at assignment number 2 on modeling, let's just walk through the solution is at the bottom of that. Okay. So here you needed to use the bike sharing data. The way to kind of do question number 2, where here you wanted to get all of the missing values, you wanted to turn them to zeros. Remember, when you're using LOC, the first argument is a logical condition that evaluates to true and false. Well, way back when we did profiling, remember when we do missing data, we say dot is NA dot sum. Well, the dot is an A is a function that turns everything to true false based on whether it's missing data. And so if something's missing a value, it would be true using this function, which is exactly what I want here. This is basically saying, look in the rainfall corrected column, corrected, yep, and anything that's true, which means anything that's missing, in that column, change to a 0, okay? A few of you used fill NA, and I did allow that. That's a pretty common way to do this as well. So I did allow that as well. The average was 0.152. This one, again, I think most people got this right. A few of you use PD.NA, which is from Pandas. But again, this is what we covered in class from NumPy, np.nan. Okay. This one, a few people lost points because you forgot to do an assignment statement. Remember, if all you do is run this code without the df equals, you're actually not saving the data frame. You're creating a new data frame temporarily for the output here, but it actually doesn't save. To actually save the rename, you have to use df equals. Okay. This one, the majority of people that lost points here, it's because you did a loc on both sides of the equal sign, which might have gotten you to the correct answer, but you don't need that, right? Loc is just locating the rows and columns that I then want to change. So on the left side of the equal sign, I'm locating any row with a date before this date, and I'm looking at the temperature column. And then what do I want to do for any of those rows and column? I want to subtract 11 from temperature. Okay, so you don't need dfloc. And in fact, I think that if you use dfloc on the right side as well as the left side, you're more apt to make a mistake that's going to get you the wrong number. Okay, so you only need loc on the left side of the equal sign. You're locating those rows and columns. The right side then says, what do I want to change those rows and columns to? Okay, almost everyone got the weekday column correct. Almost everyone got this correct. Most people built their model correctly. You might have gotten different numbers based on what happened up here. Okay, so if you got wrong numbers up here, then you're going to get different results. I accounted for that. So if you messed up here, you lost points up here for getting something wrong, but I didn't deduct again for that down here. I just looked at your results based on what your model said. Okay, so the first question asked how strong the model is. For that, you're going to use R squared. 36.3% of the variability in rented bike count is explained by this model. Not terribly strong. The second question asks which day of the week is predicted to have the highest bike rentals. Well, notice all of these weekdays have a negative coefficient. Some of you said Wednesday because it's the least negative. But remember, with categorical variables, one category is left out as the reference or baseline category. It's alphabetical, Friday. Notice we don't have Friday in the output here. All of these numbers are compared to Friday. And so the fact that all of these numbers have a negative coefficient, it means that all of these days are predicted to have fewer bike rentals than Friday. Okay. And then finally, I asked you to interpret temperature. Okay, and so temperature, it is statistically significant. Again, the correct answer is 30. Some of you got like 28 or 23 based on errors up above. The way you would interpret this is for a 1 degree Celsius increase in temperature, the rented bike counts are expected to increase by 30 bikes on average when you hold the other variables constant. Okay, that's how you would interpret that. Predictive modeling. The biggest mistake people made was some people created dummies for everything, including the numeric variables. You do not make dummies for numeric variables, okay? A couple people couldn't get their model to run because they included the categoricals in their numeric features, which means that they had columns, when you look at features, they had columns that were using words instead of just true false. Okay, so remember, it's important. You separate out the numerics and you create dummies for the categoricals, and then you concatenate them both together. A few of you lost 1 point because you did everything with get dummies and you just specified. So you put all of the variables in this get dummies function, but then you specified to only create dummies for those two columns. And while technically that works, that was coding that differed from what we did in class. Remember, I'm grading you based on what we did in class. In class, we created numeric features, dummy variables, and then we concatenated them both together. So just make sure you do that on the exam, because you're likely to have a question where you're going to have to build a machine learning model. I do want you to adhere to the modeling techniques from class. Okay. Partitioning was pretty straightforward. Building the model for the most part was pretty straightforward. I asked about how accurate the model is on new data. So specifically, I was looking for the accuracy for the test data. Remember, the test data is a stand-in for new data. This model is about 84% accurate with the test data. Okay. A few of you ran the model and you only got output for the test data and you didn't look at the training data. I did not mark you wrong for that, but I don't think that's a great practice, because if you don't look at the training data, you cannot assess whether or not there's overfitting. Okay, I didn't ask about overfitting, so I did not deduct for that, but clearly we have overfitting, right? We're going from 84% up to 100%, right? Whenever there's an increase of more than 10%, I think that's a clear case of overfitting. In this case, it's 16% difference. We clearly have overfitting here. If I had asked a question about overfitting and you only looked at the test data, you wouldn't have been able to answer that question. So I highly, highly recommend that you include results for both training as well as test data to really get a sense of how the model's working. Okay, so that was assignment number 2. Let's look at the 2 connections assignments, quickly talk about those. So connections 1, I don't think I've talked about this one yet. Again, I've posted a solution file down here. So here I gave you complex data or complex code that was given to me by Microsoft Copilot, and I wanted you to simplify this. Basically, I was looking for you to get down to something like this. Okay, read in the data, preview the data. We need data types, the missing values, summary statistics, value counts for those 2 variables, and a histogram for speed. Okay, that's really all this is doing, right? This is just loading and previewing the data. This is giving me the nulls, okay? I don't need all this code, right? I can just say is na.sum, okay? A few of you did, because technically this code did have a calculation for percentage of missing data. I didn't mark you wrong either way if you didn't include code for a percentage, or if you did include code. We didn't really talk about that, so I kind of ignored that. But a few of you actually noticed that if you say isNA.mean, it actually gives you percentages. That's actually probably the easiest way to do that. Is you could just say isNA.mean instead of .sum. Okay, because the mean of a binary true-false variable would be the average percentage of trues. That's what a mean gives you. Okay, but notice up here, like with the target categoricals, it's got this whole for loop just to give you value counts. Just all we needed were 2 different value counts. And again, this has a whole bunch of complex code to create titles and labels. Remember, when you're doing data profiling for yourself, you just want to look at the data. You don't need to create titles. You don't need to create axis labels. Now, this week, when we're looking at ggplot, I call that explanatory visualization, where you're creating graphs for other people to look at. Then in that case, you do want to make sure you have good titles, good axis labels, because you're giving the graph to someone else to look at. But when you're just profiling the data for yourself, you don't need to waste time creating like lots of titles and axis labels. Just look at the data, right? So that was the first connections assignment. The second connections assignment, here I wanted you to use AI to actually create a graph with Plot9. Again, I've posted a solution file. And basically, as long as you gave me a copy of your conversation, I did want to make sure that you had a conversation. And as long as you got close to this graph, I gave you credit. Where people lost points was sometimes, let me see if actually, do I still have this open? Let me see if I can find this here. Okay, I found it. So here's typically what happens. So first, let's just kind of look at this graph, okay? Um, here we go. So this graph looks very similar to the graph that I gave you. The problem is, notice it's not using ggplot. It's not using plot9. And so I had specified I wanted you to use ggplot. Part of the reason is that I wanted to give you a preview of ggplot the week before you're learning about ggplot. Like this week, you're learning about how ggplot works. And so I kind of wanted to give you a preview of that using AI. The second thing is here we're using ggplot, right? Here I've got ggplot. Again, the graph looks pretty correct. It's a little bit different, but pretty close. But if you look up here, notice it actually is creating a fake data frame. And if this happened for a few of you, it didn't actually use the real data. And my guess is the way this happened is you gave it a copy of the graph so that it could look at the numbers. And then it just created like a temporary data frame. So you lost points for that because this graph is based on fake data. Okay. Here's one where it's using ggplot. So we're using ggplot. Let's see. Yep, we're using ggplot here. There we go. The graph looks pretty good. Look at how complex this code is. It is using the real data, so it's reading in the correct data, but it's got like an if statement. We're changing data types and stripping stuff from the data. We're ordering the payment card order. We're doing it's creating like a bunch of different code for the text for the title and legend and all that stuff. It's doing a lot of extra stuff. Here's the code that I used to create that graph. Okay, the graph that I included, that's all there is. Okay, and by the way, this week you're learning enough to be able to create this graph, right? Where it's just giving it's a bar chart. It's position equals Dodge means it's a side-by-side bar chart. The X variable is payment. The fill variable, which is this legend, is the card variable. I'm changing the labels. So X I'm calling payment. Y I'm calling count of customers. The title I'm giving is that. And then I'm just specifying with scale fill manual, specifying gold and maroon. Okay, that's all I did. This is pretty simple code. And so part of the reason that I take you through this is, first of all, to kind of watch out for things like this, where it's leading you down the wrong path. This is the wrong function, the wrong package, or it's using fake data. That's the risk that you have when you give it like a graph. It's just going to try to duplicate the graph that it sees without actually plugging into the actual data set. Or it gives you code that's like way too complex. This is way more than need. All of this theme stuff, it was totally unnecessary. Totally unnecessary. I didn't use any theme things. In this class, we're not covering themes. And I didn't use them, right? These are all defaults, okay? Other than the colors that I'm using for the bars, everything else is a default. And so, part of the experience of going through that exercise is to give you a little sense of that. That first of all, what I noticed most of you kind of said is it's amazing how powerful Copilot can be. I have found that Copilot, particularly these days, when I first did this assignment, it was much more frustrating for people. I will say that Copilot has gotten good enough at this that on the first try, it's probably about 80% there. Depending on how you phrase and word your prompt, it's probably about 80% of the way there. And then the last 20% is you just trying to get it to have the right labels or the right colors, okay? That part can be very frustrating. And so if you don't know how the code works, it's very difficult to assess what it's giving you, okay? If you don't know how the code works and you see this stuff, I mean, that's a lot to go through, right, to figure out what's going on here. And so that's the risk. That's kind of the downside to using AI for coding. Okay, it can be difficult, particularly if you don't know how the code works. It can be very difficult to assess and evaluate. So my guess is for people that gave me graphs that looked like this, that were using ggplot, but didn't have the right data frame, it's partly because there's so much here that you probably just didn't even know what's happening, right? You kind of have to dig in to see, aha, this is the wrong data, right? This is the wrong data. This is not the credit card default reduced.csv data file that we needed to use. Okay, so that's really the takeaway from that second connections assignment. Okay, hopefully you found that helpful. Again, there's a lot there. Um, for this week, just as a reminder, as I mentioned, this upcoming Monday, your final knowledge check 5 is due, as well as the final assignment number 3 on visualization. As a reminder, no late submissions on that because I'm posting the solution file for that next Tuesday. So that does need to be in by Monday night. Okay, and then the only other thing is next week, the exam, which will be open on Monday through Friday of next week. You can take it at any point, 2.5 hours. You can't pause it once you start it. So just make sure you have a good 2.5 hour chunk of time before you start that exam. And then we're done. Okay. As always, let me know if you have any questions or any issues come up. Otherwise, I'll see you next week. Bye-bye.